All right. I suppose we can kick things off, and if folks join later, they no problem. So, welcome to another Modzy Tech Talk. Let's see if we can get our slides going. Just the preliminaries. In let's see, next week we're going to be doing automatic model containerization, which is going to be a really cool talk. Basically, how data scientists don't have to learn anything at all about Docker because we're going to take your SageMaker ML flow experiments and just automatically roll them up into a tarball that you can deploy wherever you want. KF serving, Modzy, of course, or just whatever your microservices framework is, but it'll all be containerized. The next two talks in March we are about to announce, so I won't spoil them here yet. And I think Kirsten can correct me, but I think we might have one slot still open, so get your recommendations in for that talk if anyone has any ideas that they'd like to hear discussed. And yeah, again, every Friday, 1 p.m. Eastern, we're doing this, and feel free to jump on over to the general voice channel afterward, where we'll have just an open Q&A, open discussion, always interesting thoughts. So yeah, I was here a couple of weeks ago and just gave kind of a general overview of using integrations with Modzy and just using integrations with ML and AI in general. And so today I'm going to really focus in on a single integration, and that's Tableau. So hopefully y'all are Tableau users. If not, this might seem a little odd, but in general, Tableau is gaining popularity. You've probably seen it used in a whole bunch of charts. I think I've seen a dozen governments around the world using it to display their COVID rates and their various things. We've seen Tableau used in our local DMV to show time of appointments and time required to actually get in there and do something. So I'm starting to see it anywhere and everywhere. And for those who aren't super familiar with Tableau, it's broken into a set of products. There's a prep, there's a desktop, and of course there's the online and server stuff that is, what you've probably seen. But Tableau in general is just a very advanced way to visualize your data, to make charts, to make dashboards. Things can be alive, not necessarily static. But it can be used for a whole bunch of fun ways to just explore data and visualize it and display it to other folks. But one of the weaknesses of Tableau is that it's exclusively used for structured data. So great, if you have all of your data in a nice Excel sheet, you can import that to Tableau, or a nice SQL database, you can display that in Tableau. But so much of data these days is contained within unstructured sources like image files, like video, like audio. Tableau can't really do anything at all with those. They don't have a function to import it. They don't have any native ability to look at those things. They wouldn't even know really what your goal is in looking at those to begin with. So traditionally, this isn't the domain of Tableau, but with artificial intelligence, with machine learning, with computer vision models or NLP models, we're going to explore how to kind of extract, categorize, maybe quantify all the data held up in those data sources. So specifically, today we're going to explore aerial imagery. A very common use case that I see that I mentioned in the last talk is just counting cars. It's weirdly common. Maybe I'm an investment banker and I want to count cars in a parking lot to see if a particular store is doing well or a warehouse has reopened after a closure. Or maybe I'm a city manager and I just want to characterize the usage of certain roads or certain freeways. But cars are a very good they're a very good indicator for a lot of topics that people are looking to explore. So often your data set's going to look something like this: hundreds or thousands of georeferenced tiles in an area that's hundreds or thousands of kilometers large. You could run you could pull this source data from QGIS or ArcGIS. You could, in fact, run what I'm about to show you in one of those tools as well, but we're just going to stick within Tableau for today, because I know y'all aren't necessarily GIS engineers. That'll be a future talk. So anyway, I think this is a good summary of what I'm about to do. We're going to analyze data, and we're going to create a whole bunch more data. And it was just too appropriate to not include here. So with that said, let's just jump right in. As Seth mentioned a few minutes ago, we have made available this vehicle detection and aerial imagery model. It does run on a GPU, so we're going to be allowing you to use one of these GPU models every month. It's our model of the month, and this will be our first one. So everything that we're running through today, you can actually run yourselves through app.modzy.com. Feel free to play around with it and have some fun and come up with some interesting results. We're going to be using the API, specifically the Python API in this example, because Tableau does have a very nice Python server that it can run arbitrary scripts with. So that said, let's just jump over into Tableau itself. This is Tableau Prep, pretty blank slate, but we're going to connect to our data. In this case, I've made a little text file, basically just of every single image in my data collection. Again, this could be hundreds to thousands to tens of thousands of images, depending on the size of the area I'm analyzing. And for today, to keep things fast, I'm just going to use this little subset of images. Tableau is going to import those, and it's going to try to parse them because Tableau is really good about trying to help you out, but I'm going to tell it each individual line is its own file. So we're not going to look any deeper than that. Tableau, keep your hands off. From there, we're just going to add a script. Again, we could do an R script, but I'm partial to Python, so I'm going to run the Tableau Python or TabPy server. And for that script itself, remember we mentioned we'll use this Python, and I'm going to drop it into just a new script file here. Use the IDE of your choice. Normally, I'd kind of gloss over this part, but today is a tech talk, so we'll go a little bit deeper into the actual code. I haven't changed very much here. I've added my private key. I've added my API that's specific to app.modzy.com. But this could be your own internal usage, your own internal Modzy server. And then I've changed this input data. So in the example, it's just a single file, and it has a placeholder name. I've dropped this into a for loop so that every single file that Tableau sends over to this script will be presented here in a giant batch job. I'm also using, you can see this DF. Everything in Tableau is actually a data frame. So internally, Tableau likes to use data frames, and you can kind of review the Tableau documentation to really see how that's structured. But essentially, I know that my source file is just a single column, so I'm taking that first column of data and importing that as the image address. These are, again, just copied and pasted. We're creating a job, and we're querying for those results. And then this last line here, again, Tableau likes to have everything as a data frame. So I'm taking the JSON results that the model provides, and I'm converting it into a data frame that Tableau can read. This script here is actually down at the bottom. It looks a little complex. That's basically because I'm loading and converting geodata. So I'm using the GDAL library to open it and then get a bunch of data out of it. So again, each tile is georeferenced. So I'm pulling that georeference data out and saving it. And then I go through and I actually, the model itself creates bounding boxes, but Tableau is better at displaying points than boxes. So I'm converting those bounding boxes into just a center point, an X and a Y, and I'm giving that center point the geodata that I've pulled from the tile, and then I'm returning it as a data frame. Data frame, all I want is the score, the latitude and longitude, and then the name of the image that the vehicle was discovered in. So the last thing Tableau likes is not just to have all that in a data frame, but also to know what that data frame contains. It wants to know if it's, a floating point. It wants to know if it's a string of characters, a Boolean, a blob. It's got, about 8 different data types. So you have to let Tableau know what data type you're returning. All in all, aside from the geodata stuff, a pretty simple script and basically copied and pasted from the example script that we provide you on Modzy. So if we jump back over to Tableau, we're going to browse to that script that we just created. And then I actually need to provide the function name, which I forgot to copy and paste. So let's grab that, vehicle detection prep, paste it in here, and Tableau loads. We see the latitude, we see the longitude, we see everything that we're expecting. So from there, I'm going to keep this simple. This is Tableau Prep, allows you to do has a lot of power, allows you to do a lot of things. I could add a dozen steps, I could add branches, I could add more preliminary data cleansing steps, but I'm just going to go ahead and create a static output file. In practice, I would probably publish this either to a SQL database or some sort of a live location so that my dashboards could access it no matter where in the world they are being pulled up from. But I'll just save it to a static, and I'm going to keep it within Tableau's standard .hyper format, but we could just make a CSV or an Excel file. When I click Run Flow, of course, I have to replace the one that I just made half an hour ago testing this out, but it's going to kick off that flow. And if we want to, we can jump over to Modzy and actually observe that. Oh, that's Seth's job. Maybe Seth's following along here. But we can see, here are the 7 images that we sent it, and we are getting reasonable results. So if we jump back over here, it took about 18 seconds to analyze those, and it's done. We have some nice latitudes and longitudes here. They look reasonable. Those do look like coordinates in my mind. So I think that this worked. But for the final step, I'm actually going to load it into Tableau Desktop. So the previous app was Tableau Prep, where we can run a lot of data preparation. Tableau Desktop is where we can start generating those dashboards, visualizations, all that sort of stuff. So if we connect in, you can connect to just about any data source possible. Tableau's done a great job of that. If we just connect to that result that we just created, again, here's the latitudes, longitudes, the scores, everything that we're expecting. We'll check out a new sheet. We'll drag over the data that we pulled in, and Tableau makes a nice little map. It is centered in LA, which is what I was expecting because that's where my data source, the image set, came from. Right now we're displaying averages, so if we actually say these are dimensions, we get a whole bunch of discrete dots, and they vaguely look like cars, on freeways, or parked along streets or in parking lots. So the data is working out pretty well. I can actually go one more step and display a background map. So let's just jump into a satellite. And yeah, that worked really, really well. We have a lot of cars parked in parking lots, parked along the sides of roads, that sort of thing. Satellite base map that we're looking at is not the same as the data we processed. So you're not going to see these dots line up exactly. But the fact that they are in parking lots and along roads means that we can be pretty sure that we have the accuracy we want. If we wanted to go back through and check out each individual image, see if it lines up with the dot, maybe reevaluate how certain we are that these are correct, we could do that, just kind of an exercise for a later date. But all in all, I'd say that we took unstructured data, we took an aerial imagery set, and we wanted to know, we wanted to extract data from that. This is data that you can't normally use in an application like Tableau or Excel or something that only has the ability to work with structured data. And so we used machine learning, specifically a computer vision model, to extract structured data from that unstructured imagery, and then we can start using it now in further and deeper analysis. So pretty useful, extremely concrete example of actually using AI and ML in the real world, and with tools that maybe a data scientist doesn't necessarily use, but the analysts who are using your models are, they live and breathe in tools like Tableau.